Not all disasters arrive with explosions, alarms, or visible warnings. Some begin quietly, almost invisibly, as a choice that seems reasonable at the time. A shortcut, a compromise, an assumption made because it feels safer to believe the world will continue as it always has. History shows us that humanity's most dangerous mistake was not a single invention, war, or decision, but a recurring pattern of believing we fully understood forces that we barely grasped. This script is not about blame. It is about reflection, about how progress, curiosity, fear, and confidence sometimes aligned in ways that pushed humanity forward while quietly placing us on the edge of irreversible consequences. Across civilizations and centuries, humans have repeatedly made one fundamental error: mistaking control for understanding. This mistake has appeared in different forms, under different names, and with different intentions, but its core remains unchanged. In this story, we will move slowly through that realization. Each section explores a different dimension of the same underlying mistake, not through panic or sensationalism, but through calm observation. Because the most dangerous truths are not the loudest ones. They are the ones we live with every day. Section 1. When humans believed nature could be fully controlled, long before machines, laboratories, or global systems existed, humans learned to shape their environment. This ability was our greatest strength. Fire warmed us. Agriculture fed us. Rivers were redirected. Forests cleared. Animals domesticated. Each success reinforced a simple belief: nature could be managed, predicted, and ultimately controlled. At first, this belief seemed entirely justified. Life improved. Survival became more stable. Civilization was born. But hidden within this success was the seed of the most dangerous mistake humanity would ever repeat. Early societies did not see nature as fragile. It appeared endless. Rivers always flowed. Soil always renewed itself. Forests seemed to stretch forever beyond the horizon. When land became exhausted, people moved. When water failed, they dug deeper. There was no immediate reason to think limits existed. Nature appeared vast enough to absorb any action humans took. This assumption shaped civilizations. Irrigation systems in Mesopotamia transformed deserts into farmland. But over time, salt built up in the soil, silently poisoning the land. Ancient societies did not recognize this as a warning. They saw it as an unfortunate mystery. The same pattern appeared in other regions. Forests were cleared for ships, cities, and fuel, only for erosion to weaken entire landscapes generations later. Each decision made sense in the moment. The danger unfolded slowly, beyond the lifespan of those who made it. The most dangerous part of this mistake was not the damage itself, but the delay between cause and consequence. Human minds are poorly equipped to sense slow-moving disasters. We respond to immediate threats, not gradual ones. A fire demands attention. A famine decades in the making does not. As a result, early societies continued expanding, draining wetlands, overusing soil, and hunting species to extinction, never fully connecting their actions to the outcomes that followed. Collapse seemed sudden, even though it was quietly constructed over centuries. This illusion of control deepened as technology improved. Tools became more precise. Structures grew larger. Humans learned to bend rivers, reshape coastlines, and extract resources buried deep underground. With every new capability, confidence increased. The belief solidified. If something could be built, it could be managed. If it could be managed, it could be fixed later. What was missed was the complexity beneath the surface. Nature is not a machine. It is a web of systems layered upon systems, many of which respond in non-linear ways. Small interventions can produce massive consequences, while large efforts sometimes do nothing at all. Ancient engineers did not know about feedback loops, tipping points, or ecological thresholds, but their absence of knowledge did not prevent those forces from operating. The pattern repeated across cultures. The Maya reshaped forests and water systems until droughts became catastrophic. Easter Island's deforestation unfolded slowly, one tree at a time, until the society that depended on those trees lost the ability to sustain itself. These were not foolish societies. They were intelligent, organized, and innovative. Their mistake was not ignorance. It was overconfidence born from previous success. And this is what makes the mistake so dangerous. Success teaches us the wrong lesson. When actions produce short-term benefits, we assume they are safe long-term. When systems continue functioning, we assume they always will. When consequences are delayed, responsibility becomes blurred across generations. By the time damage becomes undeniable, it often feels too large to reverse. Even more unsettling is that this mistake was not confined to the past. The same mindset followed humanity into the modern age. The scale changed, but the pattern remained intact. Nature was still viewed as something external, something separate from human systems, something that could absorb pressure indefinitely. At no point did humanity collectively pause and ask a fundamental question. What if control is an illusion? Instead, we learned to trust models, measurements, and predictions that simplified reality into manageable pieces. These tools were useful, but incomplete. They gave the appearance of mastery, while hiding uncertainty beneath layers of calculation. Each success reinforced the belief that complexity could be reduced without consequence. The calm danger of this mistake lies in how reasonable it feels. It does not arrive as recklessness. It arrives as planning, as progress, as confidence backed by evidence, until the evidence runs out. By believing nature could be fully controlled, humanity unknowingly placed itself inside systems it could influence but not command. systems that respond slowly, accumulate pressure quietly, and fail suddenly. This belief did not lead to immediate destruction. It led to delayed vulnerability, the most dangerous kind. And once that belief became embedded in civilization itself, it became extraordinarily difficult to challenge. Because to question it would mean questioning the foundation of progress, comfort, and modern life. This is where the most dangerous mistake truly begins, not with destruction, but with certainty. Section 2. The illusion of knowledge and the confidence that followed. As human societies grew more complex, another layer was added to the most dangerous mistake, the belief that knowing more automatically meant understanding enough. Knowledge expanded rapidly through writing, mathematics, philosophy, and later science, but understanding lagged behind in subtle ways that were easy to overlook. This gap between information and true comprehension became one of the quiet engines driving humanity toward unintended consequences. Early knowledge was hard-earned and precious. When humans learned to predict seasons, chart stars, or calculate distances, these abilities felt almost magical. Patterns were discovered, rules were written down, and the world became more predictable than it had ever been before. This predictability created safety, and safety created confidence. Over time, confidence hardened into something more dangerous: certainty. Certainty is comforting. It allows decisions to be made quickly. It silences doubt. It turns unknowns into footnotes rather than warnings. As civilizations accumulated knowledge, they also accumulated the assumption that unknowns were shrinking, when in reality, they were only becoming harder to see. This illusion deepened with formal systems of thought. Philosophy taught humans to reason logically. Mathematics taught them to describe reality precisely. Early science taught them to isolate variables and test outcomes. These were powerful tools, but they worked best in controlled environments. The real world, however, is never fully controlled. As methods improved, humans began mistaking precision for completeness. If something could be measured, it felt understood. If it could be described in equations or written laws, it felt mastered. What went unnoticed was everything that could not yet be measured, or that was dismissed as insignificant noise. History shows this pattern repeating again and again. Societies built systems based on the best knowledge available at the time, assuming gaps would not matter. In medicine, treatments were applied confidently before long-term effects were understood. In engineering, materials were used without knowing how they would age. In governance, economic models were trusted to behave as predicted, even when human behavior refused to follow clean logic. Each time, the same logic appeared. We know enough to proceed. The danger did not lie in acting on incomplete knowledge. That is unavoidable. The danger lay in failing to acknowledge that knowledge was incomplete at all. Once uncertainty is dismissed, safeguards weaken. Doubt becomes inconvenient. Warnings are seen as obstacles rather than information. One of the most subtle aspects of this mistake is how success hides its flaws. When systems work most of the time, failures are treated as exceptions. When predictions are usually accurate, errors are blamed on external factors. Over time, confidence grows faster than humility. The unknown does not disappear, it simply becomes ignored. This mindset shaped humanity's relationship with risk. Instead of asking, "What don't we know?" societies increasingly asked, "How fast can we move forward?" Progress became linear in imagination, even though reality is never linear. Feedback loops, thresholds, and cascading effects remained poorly understood, even as decisions affecting millions or billions were made. Another layer of danger emerged when knowledge became specialized. As fields grew more complex, no single person could understand entire systems. This specialization was necessary, but it fragmented responsibility. Each expert focused on their portion, trusting that others were managing the rest. The whole became abstract, and with abstraction came distance. Distance dulls caution. When consequences are spread across time, geography, or populations, they lose emotional weight. A decision made in one place might affect people decades later in another part of the world. This separation made it easier to proceed without fully grappling with outcomes. The system, it was assumed, would balance itself. But systems do not balance themselves out of kindness. They follow rules, rules that humans often only discover after crossing critical thresholds. The most dangerous mistake here was not arrogance in the loud, dramatic sense. It was quiet overconfidence, the kind that sits comfortably in meeting rooms, research papers, and long-term plans, the kind that believes caution is built into the process, simply because the process looks rational. Over time, this confidence reshaped how humanity responded to warnings. Early signs of trouble were debated instead of addressed. Uncertainty was treated as weakness rather than as essential information. When predictions conflicted, the most convenient one was often chosen, not because people were malicious, but because systems reward stability and momentum over hesitation. This is how slow-moving dangers survive scrutiny. They are always just uncertain enough to delay action, just abstract enough to avoid urgency. Meanwhile, complexity accumulates. Interdependence grows. Systems become harder to change without disruption. What makes this mistake especially dangerous is that it often feels like wisdom. After all, humanity has learned a great deal. We have solved problems our ancestors could not imagine. That success makes it emotionally difficult to accept that knowledge can grow while understanding remains fragile. In truth, the more complex a system becomes, the easier it is to misunderstand it. Interactions multiply faster than insights. Small errors compound. Feedback loops emerge where none were expected. By the time consequences become visible, they often appear disconnected from their origins. This creates a final, unsettling illusion that disasters are sudden, unpredictable events, rather than the delayed result of long-running assumptions. In reality, many of humanity's gravest outcomes were not caused by ignorance, but by misplaced confidence in partial understanding. By believing knowledge was synonymous with control, humans gradually built systems that were impressive, efficient, and quietly vulnerable. The most dangerous mistake continued to evolve, not as a single decision, but as a mindset. We know enough to continue, and whatever we don't know will not matter. History suggests otherwise. Section 3. When small decisions scaled beyond control. One of the most dangerous qualities of the greatest human mistake is that it almost never begins as something large. It begins quietly, with decisions that seem reasonable, limited, even harmless. A single choice made for convenience, a shortcut taken to save time, an efficiency gained to reduce cost. Each step feels minor, especially when judged in isolation. But history shows that danger does not come from the size of a decision. It comes from how far that decision is allowed to scale. Early human societies lived close to the consequences of their actions. When a forest was overused, firewood ran out nearby. When land was exhausted, crops failed within sight of those who planted them. Feedback was fast, personal, and difficult to ignore. This proximity acted as a natural brake on excess. Mistakes hurt quickly, and lessons were learned the hard way. As civilizations expanded, this feedback slowed down. Decisions began affecting places far away or people not yet born. Cause and effect drifted apart in time and space. What once felt immediate became abstract, and abstraction is fertile ground for unintended consequences. A single innovation adopted by one group might remain harmless. Adopted by many, it reshapes entire systems. Adopted by everyone, it becomes irreversible. This is where scaling quietly transforms neutral actions into dangerous ones. A technique that works well at small scale may fail catastrophically when applied universally. Early agriculture, for example, improved food security locally. When expanded massively, it altered ecosystems, soil health, and population dynamics in ways no early farmer could have predicted. Each farmer made rational choices. The system that emerged was something no one fully intended. This pattern repeats across history. Tools, policies, technologies, and habits spread because they work at first. Success accelerates adoption. Adoption increases dependency. Dependency reduces flexibility. Eventually, society becomes locked into systems that are difficult to stop even when their flaws become visible. What makes this particularly dangerous is that early success suppresses caution. When outcomes are positive, warnings sound pessimistic. When benefits are immediate, risks that lie decades away feel hypothetical. The human brain is not well equipped to emotionally process slow-moving threats, especially when they are born from actions that feel productive and intelligent. Scaling also hides responsibility. No single person causes the outcome. Each participant contributes a fraction, so small it feels insignificant. A village cuts trees, a city imports timber, a nation industrializes forestry. Each step is logical. The result, a destabilized environment, emerges without a single villain. This diffusion of responsibility makes correction difficult. When harm appears, no one feels fully accountable. Systems are blamed, circumstances are cited, momentum continues. Another danger of scaling is standardization. As systems grow, they become optimized for efficiency rather than resilience. Diversity is replaced with uniform solutions because uniformity is easier to manage. But uniform systems fail uniformly. A single flaw can propagate everywhere at once. In early societies, different groups solved problems in different ways. If one approach failed, others survived. As human systems became global, failure stopped being local. It became synchronized. A bad assumption embedded deeply enough could affect entire continents. This is where the most dangerous mistake deepens. Humans confuse scalability with safety. If something can be expanded smoothly, it is assumed to be sound. But smooth expansion often hides fragility. Systems optimized for growth are often brittle when stressed. Once large-scale systems are established, reversing them becomes emotionally and economically painful. People build lives around them. Institutions depend on them. Entire cultures adapt to their rhythms. Even when flaws are acknowledged, the cost of change feels too high, so adjustments are delayed. Temporary fixes are applied. Long-term risks are postponed. This delay compounds danger. Small corrections made early prevent collapse. Large corrections made late cause disruption. Faced with disruption, societies often choose delay again. There is also a psychological comfort in scale. Large systems feel stable simply because they are large. They appear permanent. This illusion of permanence makes warnings feel exaggerated. Humans assume tomorrow will resemble today because yesterday did. Yet systems often appear stable right up until the moment they are not. History shows that collapse is rarely sudden from the inside. It feels gradual, manageable, and familiar until it is no longer within control. By the time consequences accelerate, options have narrowed. Another quiet aspect of scaling is how it changes values. What begins as a tool to serve human needs can become a system humans serve instead. Efficiency metrics replace human judgment. Output becomes more important than impact. Success is measured by growth rather than sustainability. When this happens, questioning the system feels like questioning progress itself. Critics are labeled resistant, emotional, or unrealistic. Momentum gains moral weight. Stopping feels like failure. The most dangerous mistake here is not expansion itself. Growth is natural. The mistake is assuming that what works today will continue to work indefinitely, regardless of scale. Nature does not operate this way. Thresholds exist everywhere. Systems absorb stress until they don't. What makes this mistake especially tragic is that humans often recognize it only in hindsight. After consequences unfold, the path becomes obvious. People look back and say, the The signs were there, and they usually were. But while standing inside the system, those signs were fragmented, debated, and easy to dismiss. Scaling turns small decisions into historical forces. It transforms individual intentions into collective outcomes no one explicitly chose. And once those outcomes are embedded, undoing them requires not just knowledge, but courage, coordination, and sacrifice. This is why the most dangerous mistake is rarely dramatic. It is cumulative. It grows quietly alongside success. It rewards confidence, speed, and certainty, while punishing patience and restraint. By the time humanity realizes a system has grown beyond control, the system often controls humanity. Section 4. When knowledge outpaced wisdom. One of the most dangerous turning points in human history came not when people lacked knowledge, but when knowledge advanced faster than wisdom. This imbalance has appeared repeatedly, and each time it has carried consequences that were slow to emerge, but enormous in scale. Humans became very good at doing things long before they became equally good at understanding what those things would ultimately mean. Early human knowledge grew through observation and necessity. Fire was learned through danger. Tools were refined through failure. Each advance carried immediate feedback. Mistakes burned, starved, or injured the people who made them. Wisdom and knowledge evolved together because survival demanded it. As societies developed, knowledge began to accumulate more rapidly. Writing preserved discoveries. Mathematics abstracted reality. Science separated cause from belief. These were extraordinary achievements, but they also introduced distance between action and consequence. A person could design something without ever witnessing its full effect. This separation is subtle but profound. Wisdom is shaped by lived experience and long-term thinking. Knowledge, especially technical knowledge, can expand independently of ethical reflection. When the two drift apart, humans gain power faster than they gain restraint. History shows that humans are often careful when something is new and poorly understood. Fear creates caution, but once a technology becomes familiar, caution fades. Confidence grows. Control is assumed. The unknown becomes background noise. This is the moment when danger quietly increases. Powerful tools tend to be normalized before they are fully understood. Early successes reinforce belief in mastery. Failures are framed as anomalies. Risks are acknowledged academically, but ignored behaviorally. The human mind adapts to danger by learning to live beside it rather than confronting it. Knowledge also fragments responsibility. One person develops theory, another applies it, another commercializes it, another governs it. Each sees only part of the whole. Wisdom, which requires holistic understanding, struggles to exist within such fragmentation. This is why so many dangerous outcomes emerge from systems where no individual intended harm. Each contributor acted rationally within their limited scope. The system as a whole, however, operated without unified moral oversight. Another problem arises when knowledge is rewarded more than wisdom. Societies often celebrate innovation, speed, and disruption. Slowing down to ask, should we instead of can we, is rarely incentivized. Those who raise ethical concerns are frequently sidelined as obstacles to progress. This cultural imbalance creates a dangerous feedback loop. Faster development brings prestige and power. Caution brings delay. Delay brings loss of relevance. Over time, restraint becomes associated with weakness rather than responsibility. Once this mindset takes hold, wisdom is treated as optional. There is also a tendency to believe that future solutions will fix present problems. If a new technology causes harm, people assume another technology will correct it later. This belief allows humans to postpone difficult choices. Responsibility is deferred to a future generation armed with better tools. But this assumes that damage is always reversible. History suggests otherwise. Many consequences accumulate silently and reach tipping points beyond which correction becomes impossible or extraordinarily costly. Another aspect of knowledge outpacing wisdom is the illusion of control. As systems become more complex, humans rely increasingly on models, simulations, and abstractions. These tools are powerful, but they are still simplified representations of reality. When confidence in models exceeds humility toward reality, blind spots multiply. Complex systems often behave in non-linear ways. Small inputs can cause massive outputs. Stable conditions can flip suddenly. These behaviors are difficult to predict even with advanced knowledge. Wisdom would advise caution. Knowledge alone often encourages experimentation at scale. This imbalance also affects moral distance. When actions are mediated through layers of technology, humans feel less emotionally connected to outcomes. Harm becomes statistical. Impact becomes abstract. Numbers replace faces. This emotional distancing weakens ethical resistance. A decision that would feel unacceptable if its consequences were visible can feel manageable when those consequences are distant or delayed. This psychological buffering allows dangerous practices to persist without triggering moral alarm. Over time, societies build narratives to justify this imbalance. Progress is framed as inevitable. Sacrifice is described as necessary. Costs are described as unfortunate but unavoidable. These narratives provide comfort and coherence, but they also suppress doubt. The most dangerous mistake here is not ignorance. It is overconfidence. The belief that understanding how something works automatically means understanding what it will do to the world. These are very different kinds of understanding. Wisdom requires patience, historical memory, humility, and moral imagination. It asks not only what is possible, but what is sustainable. It considers second and third order effects. It listens to uncertainty instead of silencing it. When knowledge races ahead without these qualities, humanity becomes capable of reshaping reality faster than it can responsibly guide that change. This is how well-intentioned advances become irreversible mistakes. not because humans are malicious, but because they mistake capability for readiness. The tragedy is that wisdom usually arrives eventually, but often only after consequences have already unfolded. Lessons are learned, reports are written, safeguards are proposed, but by then, systems are entrenched, damage is widespread, and options are limited. The most dangerous mistake is not learning too slowly. It is believing that learning later will always be enough. Section 5. The illusion that humans can always fix what they break. Another of the most dangerous mistakes humans have ever made is the deep, persistent belief that any damage caused today can always be repaired tomorrow. This idea is comforting. It allows progress without pause, action without restraint, and risk without immediate guilt. But history shows that this belief is often wrong, and when it is wrong, the consequences are permanent. From early civilizations onward, humans learned to manipulate their environment in increasingly powerful ways. Forests were cleared, rivers redirected, animals domesticated, land reshaped. At first, nature seemed endless. Resources appeared to renew themselves. Damage seemed local and temporary. If something went wrong, people moved elsewhere or adapted. This early experience planted a dangerous assumption that the world is resilient enough to absorb human mistakes indefinitely. As human populations grew and technologies expanded, this assumption remained. Even when evidence suggested otherwise, the belief persisted. Humans are remarkably good at fixing short-term problems, and those successes reinforced confidence. A polluted river could be cleaned. A failing harvest could be replaced with a new crop. A disease could be treated with a new medicine. Each solution strengthened the idea that problems are temporary and solvable. What was missed is that many systems do not fail all at once. They degrade slowly, quietly, and unevenly. Damage accumulates beneath the surface. Early warning signs are subtle and easy to dismiss. By the time failure becomes obvious, recovery may no longer be possible. This pattern appears again and again. Humans push systems close to their limits because nothing dramatic happens at first. Stability creates reassurance. Reassurance encourages further pressure. Eventually, a threshold is crossed, and the system behaves in ways no one expected. At that point, the belief in easy repair becomes a dangerous illusion. One reason this mistake persists is psychological distance. Many consequences unfold over decades, centuries, or even millennia. Human decision-making evolved for immediate survival, not long-term planetary management. When cause and effect are separated by time, urgency disappears. People tend to prioritize visible problems over invisible ones. A crisis today demands attention. A slow decline tomorrow can be postponed. This bias allows damage to continue uninterrupted, while humans focus on more immediate concerns. Another factor is specialization. Modern societies divide responsibility into narrow roles. Scientists study problems. Engineers design solutions. Politicians make policies. Businesses pursue efficiency. Each group sees only a fragment of the whole. No single perspective captures the full long-term impact. This fragmentation creates gaps where responsibility dissolves. When something goes wrong, no one feels fully accountable. Everyone followed their role correctly. The system itself becomes the problem. But systems are difficult to confront or change. Humans also tend to overestimate their control over complex systems. Models and predictions create confidence, but reality often behaves differently. Natural systems, social systems, and technological systems interact in ways that are non-linear and unpredictable. Small changes can trigger cascading effects. When humans assume they can always intervene later, they underestimate how quickly control can be lost. There is also a cultural attachment to optimism. Believing that problems are solvable feels hopeful and empowering. Questioning that belief can feel pessimistic or paralyzing. As a result, voices that warn of irreversible damage are often dismissed as alarmist. But realism is not pessimism. It is recognition of limits. Some changes cannot be undone. Some losses cannot be recovered. Some thresholds, once crossed, permanently alter the conditions of life. History contains many examples where humans realized this too late, when ecosystems collapsed, societies destabilized, or technologies escaped meaningful control. The illusion of fixability also encourages delay. Difficult decisions are postponed because they are uncomfortable or costly. Leaders assume future innovations will provide easier solutions. This deferral compounds risk, turning manageable problems into existential ones. Ironically, the belief in future fixes often prevents the very actions that would make repair possible. Early intervention is usually effective. Late intervention is expensive, disruptive, or futile. Another danger lies in moral hazard. When people believe that consequences can always be mitigated, they take greater risks. Responsibility weakens. Caution fades. This mindset shifts behavior across entire societies, not just individuals. Over time, this creates a world where humans operate at the edge of sustainability without realizing how close that edge truly is. What makes this mistake especially dangerous is that it often feels rational. After all, humans have fixed many things before. Technology has solved real problems. Medicine has saved lives. Engineering has prevented disasters. But past success does not guarantee future reversibility. Some systems allow recovery, others do not. The challenge lies in knowing the difference, and humans are notoriously bad at recognizing irreversible change until it has already occurred. Wisdom would demand humility, acknowledging uncertainty, respecting limits, and choosing restraint even when power is available. Instead, humans often choose confidence over caution, speed over reflection, and short-term benefit over long-term stability. The most dangerous part of this mistake is not that humans break things. It is that they break things while believing, sincerely, that nothing truly breaks forever. And history suggests that this belief, more than any single invention or decision, has quietly shaped the most irreversible consequences humanity has ever faced. Section 6. When speed became more important than wisdom. One of the most dangerous mistakes humans ever made was allowing speed to outrun wisdom. Progress accelerated faster than understanding, and momentum replaced reflection. What began as efficiency slowly transformed into recklessness, not because humans intended harm, but because they stopped asking whether they should slow down. For most of human history, change happened gradually. New tools spread slowly. Ideas took generations to reshape societies. Mistakes unfolded over time, allowing lessons to be learned before damage became irreversible. Slowness acted as a natural safety mechanism. Then something changed. Technological advancement began to move faster than human intuition could adapt. Innovations no longer took centuries to spread. They took decades, then years, then months. Each breakthrough made the next one arrive even faster. This created a feedback loop where speed itself became a value. Being first mattered more than being careful. Acting quickly mattered more than acting wisely. Speed brought obvious benefits. Faster transportation connected distant places. Faster communication spread knowledge. Faster production improved living standards. These successes reinforced the belief that acceleration was inherently good. But speed also compresses consequences. When actions happen faster than understanding, mistakes propagate before anyone realizes they exist. By the time problems appear, systems are already too large, too interconnected, and too dependent to stop easily. This is where wisdom begins to fall behind. Wisdom requires time. It depends on observation, reflection, and the slow accumulation of experience. It asks uncomfortable questions. It notices unintended consequences. Speed, by contrast, rewards decisiveness, confidence, and action, even when knowledge is incomplete. As societies accelerated, they slowly abandoned the habit of waiting to see what happens. Decisions began to be made based on projections rather than lived outcomes. Models replaced patience. Assumptions replaced proof. When something appeared to work in the short term, it was expanded immediately, often globally, before long-term effects could be measured. This pattern repeats across history. An innovation solves a problem, spreads rapidly, and only later reveals deeper costs. The danger lies not in innovation itself, but in scaling too quickly. When systems are small, mistakes are local. When systems are global, mistakes become planetary. Speed magnifies error. A flaw that would have caused minor damage in a slower world becomes catastrophic in a fast one. Another consequence of speed is decision fatigue. Humans are forced to respond constantly, leaving little space for contemplation. When everything is urgent, nothing is deeply considered. Reflection is seen as delay. Caution is mistaken for weakness. In such an environment, restraint becomes rare. Speed also changes incentives. Those who move fastest gain power, wealth, and influence. Those who hesitate are left behind. This creates pressure to act, even when uncertainty remains. Competitive systems punish careful actors and reward aggressive ones. Over time, caution disappears not because it is wrong, but because it is costly. This dynamic pushes societies toward irreversible choices. Once a system becomes widespread, removing it becomes nearly impossible. Too many livelihoods depend on it. Too much infrastructure is built around it. Too many habits are formed. At that point, even recognizing a mistake does not guarantee the ability to undo it. Speed also erodes collective memory. When change is constant, there is little time to absorb lessons from the past. Each generation inherits a world already transformed by decisions they did not make and barely understand. The origins of systems fade, but their consequences remain. Without memory, mistakes repeat. Another subtle danger is that speed creates the illusion of control. Rapid feedback can feel empowering. Immediate results encourage confidence, but fast responses often address symptoms rather than causes. Underlying problems remain untouched, quietly growing more complex. In slow systems, root causes have time to reveal themselves. In fast systems, surface-level fixes mask deeper instability. The belief that humans can always respond in time becomes itself a risk. Reaction replaces prevention. Crisis management replaces foresight. Instead of asking how to avoid disaster, societies ask how to survive the next one. And each crisis demands faster responses than the last. Eventually, humans find themselves running systems they barely understand, at speeds they can no longer safely manage. At that point, a single miscalculation can cascade beyond recovery. This is not a failure of intelligence. It is a failure of pacing. Human minds evolved to navigate environments where changes were slow and consequences were immediate. Modern systems violate both conditions. They change rapidly, and consequences unfold gradually or at massive scales. Wisdom cannot thrive under constant acceleration. The most dangerous part of this mistake is that slowing down feels impossible. Once speed becomes normalized, deceleration feels like loss. Yet without intentional slowing, reflection never catches up. History suggests that civilizations rarely collapse because they lacked intelligence. They collapse because they moved faster than their wisdom could follow. Speed is not the enemy, but speed without restraint, without humility, and without time to learn may be one of the most dangerous paths humans have ever chosen. Section 7. The illusion of control over nature. Another catastrophic mistake humans made was believing they could fully control nature without becoming subject to it. This belief did not appear overnight. It emerged slowly, reinforced by early successes, and hardened into certainty long before its consequences were understood. For most of human existence, nature dictated terms. Weather, disease, seasons, animals, and geography shaped survival. Humans adapted, observed patterns, respected limits, and developed traditions rooted in caution. Nature was unpredictable, powerful, and feared. Then humans began to win. Agriculture tamed plants. Fire bent landscapes. Rivers were redirected. Animals were domesticated. Each success weakened the ancient understanding that nature sets boundaries. Control replaced coexistence. At first, this shift was beneficial. Food security improved. Settlements expanded. Populations grew. Humans felt, for the first time, that the world could be engineered to meet their needs rather than endured. This sense of mastery became intoxicating. As technology advanced, humans stopped seeing nature as a system and began treating it as a resource. Forests became timber, rivers became energy, soil became output, animals became units. Complex ecosystems were reduced to inputs and yields. The mistake was subtle but profound. Humans optimized parts while ignoring the whole. Nature is not a machine. It is a web of interdependent systems shaped by balance, feedback, and time. When one element is altered, countless others adjust in response. These responses are rarely immediate and almost never linear. Early interventions seemed harmless because consequences lagged behind actions. A forest cut today did not collapse a climate tomorrow. A species removed did not destabilize an ecosystem instantly. This delay created the illusion that interventions were safe. By the time consequences appeared, the original decision-makers were often gone. This lag time encouraged further interference. Each success justified the next, larger manipulation. Humans began altering landscapes at scales never before attempted, assuming future solutions would fix any problems that arose. This belief that problems caused by control could always be solved with more control became self-reinforcing. One of the most dangerous aspects of this mindset is simplification. Natural systems are complex beyond complete human understanding. To manage them, humans simplified models, focusing on what could be measured and ignoring what could not. But what cannot be measured does not stop existing. Subtle relationships between insects and plants, between microbes and soil, between temperature and ocean currents were overlooked. These invisible connections quietly maintained stability. When disrupted, systems did not fail gracefully. They unraveled unpredictably. Another critical error was assuming reversibility. Humans acted as if damage could always be undone. If something went wrong, restoration would fix it. But many natural systems are fragile. Once pushed past a threshold, they do not return to their previous state. Extinction is permanent. Soil erosion can take centuries to reverse. Climate systems do not reset on command. Yet decisions were made as if nature were infinitely forgiving. Control also encouraged short-term thinking. Immediate benefits were prioritized over long-term stability. Crops were maximized. Extraction was intensified. Efficiency was rewarded. The future was treated as an abstract concept rather than a lived reality. Those who warned of consequences were often dismissed as pessimists or obstacles to progress. Over time, humans built societies dependent on constant environmental manipulation. Food systems, energy systems, and economies became fragile, reliant on precise conditions remaining stable. This reduced resilience and increased vulnerability. When nature inevitably responded, through droughts, floods, disease, or imbalance, humans were surprised. The illusion of control also fostered arrogance. Humans began to believe they stood above nature rather than within it. This psychological separation justified exploitation. If humans were outside the system, then damage was something happening to nature, not to themselves. This separation was false. Every breath, every calorie, every drop of water ties humans back into the systems they manipulate. When those systems degrade, human societies suffer, not symbolically, but physically. Perhaps the most tragic part of this mistake is that control was mistaken for understanding. True understanding requires humility, patience, and acceptance of uncertainty. Control demands dominance, certainty, and action. When control replaces understanding, warning signs are ignored, signals are overridden, complexity is denied. Nature does not negotiate, it responds, and it always responds according to rules humans did not write. The belief that nature could be mastered without consequence may be one of humanity's most dangerous errors, not because nature is cruel, but because it is indifferent. It does not punish, it balances, and balance, once lost, is never easily restored. Section 8. Trusting systems that were never tested at scale. One of the most dangerous mistakes humans ever made was assuming that systems which worked on a small scale would remain safe, stable, and predictable when expanded to control entire civilizations. This error appears again and again throughout history, quietly shaping disasters that only become obvious once they are impossible to stop. Human societies naturally grow by scaling what works. A farming method feeds one village, so it feeds 10. A political structure governs a city, so it governs an empire. A technology solves a problem locally, so it becomes universal. Scaling feels logical, efficient, and inevitable. But scale changes everything. Small systems tolerate error. Large systems amplify it. Early human tools and structures were limited in reach. If something failed, the damage was contained. A bad harvest harmed one region. A flawed law affected a city. A failed experiment endangered a few people. Recovery was possible because the system itself was small. As societies grew, humans kept building upward instead of outward in resilience. The assumption was simple. If a system functions at one level, it will function at all levels. This assumption is almost always wrong. When systems scale, new pressures emerge. Feedback loops accelerate. Dependencies multiply. Failures cascade. What was once manageable becomes catastrophic because there is no longer a fallback. One of the most dangerous aspects of large-scale systems is invisibility. As systems grow, individuals no longer see the whole. Responsibility fragments. Decisions are made far from consequences. People trust the system because they must, not because they understand it. This creates blind faith. Complex systems often appear stable right up until the moment they collapse. They hide stress rather than releasing it gradually. Instead of small failures that teach lessons, pressure builds silently until failure becomes sudden and total. Humans repeatedly misinterpret stability as safety. Another flaw is delayed feedback. Large systems respond slowly to damage. Harm accumulates over years or decades, making it difficult to trace cause and effect. By the time warning signs become undeniable, the system is already deeply entrenched. At that point, dismantling it would cause harm as well, so humans hesitate. They choose continuation over correction, hoping stability will return on its own. It rarely does. Scaling also removes adaptability. Small systems can change direction quickly. Large systems resist change because too many parts depend on the current structure. Innovation becomes risky. Flexibility becomes expensive. Stability is prioritized over survival. Ironically, the very size meant to provide security becomes a liability. Humans also tend to overestimate their understanding of systems they design. Just because a system is human-made does not mean it is human understood. Once complexity crosses a threshold, systems behave in ways no individual fully grasps. At that point, humans are no longer in control. They are operators hoping nothing goes wrong. Trust becomes mandatory. People must trust supply chains they cannot see, technologies they cannot fix, and institutions they cannot influence. When trust replaces understanding, vulnerability grows. And when such systems fail, they do not fail gently. Failure at scale means shortages, instability, panic, and rapid loss of order. Because everything is connected, damage spreads faster than response. The very efficiency of the system accelerates its collapse. Another critical error is assuming that future problem solving will outpace future risk. Humans build large systems believing that any issues will be solved later by smarter people, better tools, or new innovations. This belief pushes responsibility forward in time. But future solutions cannot always undo present commitments. Once infrastructure, habits, and dependencies are locked in, options narrow. The system demands maintenance, not transformation. What makes this mistake especially dangerous is that it feels rational. Scaling brings prosperity, efficiency, and comfort. It solves immediate problems so effectively that long-term risks seem abstract or exaggerated. Warnings are dismissed because the system appears to be working, until it isn't. History shows that civilizations rarely collapse because of a single dramatic event. They collapse because they rely too heavily on systems that cannot adapt when conditions change. The danger is not complexity itself, but untested complexity paired with overconfidence. Humans are remarkably good at building systems. They are far less skilled at recognizing when those systems have grown beyond safe limits. Trusting massive, interconnected systems without fully understanding their behavior at scale may be one of humanity's most dangerous mistakes, not because failure is certain, but because when it comes, there is nowhere left to retreat. Section 9. Believing progress automatically means improvement. Another of the most dangerous mistakes humans ever made was assuming that progress is always the same thing as improvement. Throughout history, humans have equated movement forward with movement upward. Newer meant better. Faster meant wiser. More powerful meant more advanced. This belief became so deeply ingrained that questioning progress itself began to feel irrational, even backward. Yet progress is neutral. It amplifies intent, not wisdom. Early human societies advanced slowly. Changes were tested over generations. Cultural memory acted as a brake, forcing caution. Traditions existed not only to preserve identity, but to prevent reckless change. When progress came, it was absorbed gradually, allowing mistakes to be corrected before they became irreversible. As innovation accelerated, this natural restraint disappeared. Humans began to adopt new tools, systems, and ideas faster than they could understand their consequences. The time between invention and adoption shrank. Reflection became a luxury. Momentum replaced judgment. Progress became a force rather than a choice. One of the most dangerous aspects of this mindset is moral outsourcing. Humans often assume that progress itself will solve the problems it creates. If a new technology causes harm, the belief is that a future technology will fix it. If a system creates inequality, future reforms will balance it. Responsibility is deferred to tomorrow. This creates a cycle where harm is normalized as temporary. Another problem is selective measurement. Progress is often measured using metrics that are easy to count: speed, output, efficiency, growth, while ignoring harder to measure costs such as well-being, stability, and long-term resilience. When something can be quantified, it is prioritized. When it cannot, it is dismissed. As a result, humans become very good at improving numbers while degrading conditions. Progress also narrows perspective. When societies commit to a particular vision of advancement, alternatives are labeled unrealistic or regressive. Entire ways of living are abandoned, not because they failed, but because they did not fit the narrative of progress. Once a direction is chosen, questioning it becomes taboo. This belief also fosters impatience. Slowness is seen as inefficiency. Caution is seen as fear. Restraint is mistaken for weakness. In such an environment, voices calling for limits are drowned out by those promising acceleration. Yet many of history's greatest disasters came not from stagnation, but from moving too fast in the wrong direction. Progress without pause removes the opportunity for ethical evaluation. It turns decision-making into reaction. Instead of asking whether something should be done, humans ask only whether it can be done. And if it can be done, it usually is. Another hidden danger is dependency. Each step of progress often removes older skills and systems. Redundancy disappears. Resilience erodes. Humans become reliant on newer methods without maintaining the ability to revert if those methods fail. When progress collapses, regression is not possible, only breakdown. Belief in inevitable improvement also dulls historical memory. Past warnings are ignored because humans assume they are wiser now. Ancient failures are seen as products of ignorance, not reminders of recurring human patterns. This arrogance blinds societies to repeating the same mistakes with more powerful tools. Progress also changes human behavior faster than human nature evolves. Biological instincts, formed over thousands of years, are suddenly placed into environments of constant stimulation, abstraction, and scale. Systems evolve, but humans do not adapt at the same pace. The mismatch creates stress, alienation, and instability. What makes this mistake so dangerous is that progress feels good. It brings comfort, convenience, and capability. It creates visible success stories while hiding long-term costs. By the time negative consequences become clear, the benefits are too deeply woven into daily life to abandon easily. Humans mistake familiarity for safety. True improvement requires restraint, reflection, and sometimes refusal. But progress rewards momentum, not wisdom. It pushes forward regardless of readiness. Believing that progress automatically leads to a better future may be one of humanity's most dangerous errors. Not because progress is evil, but because without judgment, it becomes directionless power. Section 10. Misjudging nature, the hubris of control. Another of humanity's most dangerous mistakes has been the persistent belief that nature is something to be conquered, controlled, and fully mastered. This misjudgment stretches back to early civilizations, but it has intensified as technology gave humans unprecedented power over the environment. Humans have always been fascinated by nature's unpredictability. From violent storms to deadly diseases, from earthquakes to floods, the natural world has repeatedly demonstrated its capacity to overwhelm human ambition. Yet, rather than respect these forces, humans often assumed they could bend them entirely to their will. Rivers were diverted, forests razed, and species eradicated, all under the banner of control and progress. Early examples, such as the draining of marshlands or the creation of artificial canals, were celebrated as feats of ingenuity, while the long-term ecological consequences were largely ignored. This belief in dominion over nature fosters hubris. Humans begin to assume that every aspect of the world is predictable, and that every variable can be calculated or engineered. Small errors or unexpected interactions are dismissed as anomalies, not as signals of the limits of human understanding. The more humans impose their will, the more they become blind to the subtle interdependencies that sustain life. Complexity becomes invisible until disaster strikes. One of the most dangerous outcomes of this mistake is ecological fragility. By simplifying ecosystems to suit human needs, we remove resilience. Monocultures, urban expansion, and industrial farming increase efficiency in the short term, but amplify the risk of collapse. When nature is treated as a set of tools, its feedback mechanisms, disease, famine, climate variability, are often underestimated. Humanity's confidence in control can thus become a catalyst for large-scale crises. This misjudgment also extends to biological manipulation. Attempts to dominate or improve human biology, whether through early eugenics movements or untested medical experiments, have repeatedly shown the peril of assuming that life can be fully engineered without ethical or unforeseen consequences. Humans often fail to recognize that life, in all its complexity, resists simplification. Interfering with natural systems without complete understanding can produce outcomes far worse than the original problem. Another element of this hubris is the belief in human exceptionalism, the idea that humans are separate from nature and exempt from its laws. This mindset has justified environmental degradation, the exploitation of resources, and the extinction of countless species. It creates moral blind spots, allowing humans to prioritize short-term gains over long-term sustainability. When humans act as though they are above the rules that govern the natural world, the resulting imbalance often rebounds with a force proportional to the arrogance that caused it. The Industrial Revolution exemplifies this mistake. Factories, chemical plants, and massive infrastructural projects reshaped landscapes and ecosystems. Pollutants once considered negligible accumulated. Rivers became contaminated, and air quality deteriorated. At the time, the prevailing belief was that science and engineering would ultimately allow humanity to solve these problems, reinforcing the notion that humans could indefinitely bend nature to their desires. Yet decades later, environmental disasters, climate change, and biodiversity loss revealed the limits of this control. Even in more subtle ways, humanity has underestimated the adaptability of nature. Invasive species, unexpected mutations, and ecological feedback loops consistently demonstrate that ecosystems evolve independently of human intentions. The belief that we can create static, perfectly managed environments is a recurring illusion that has led to countless failures, from collapsing fisheries to flooded farmlands and eroded soils, creating crises that can unfold over decades or centuries. Ultimately, the misjudgment of nature is dangerous because it combines confidence, short-sightedness, and partial understanding. Humans possess incredible ingenuity and problem-solving ability. But when this intelligence is applied without humility or awareness of complexity, it transforms from an asset into a liability. Attempts to control nature often generate new variables and risks that were invisible from the outset, turning triumph into catastrophe. The lesson embedded in this mistake is both simple and profound. Humans are not separate from nature, nor are we omnipotent. Respect, observation, and restraint are required to navigate the delicate balance of the ecosystems we inhabit. Hubris, overconfidence, and the illusion of total control remain some of the most dangerous errors humanity continues to repeat. Section 11. The Perils of Atomic Power. Playing with fire. One of humanity's most consequential and dangerous mistakes is the development and use of atomic energy without fully comprehending its destructive potential. While the discovery of nuclear fission represented a monumental leap in human understanding and technological capability, it also marked the beginning of an era where a single error or misjudgment could result in catastrophic loss of life on an unprecedented scale. The atomic bomb emerged during World War II as part of the Manhattan Project, a secret effort to harness nuclear energy for military purposes. Scientists working on the project understood the immense destructive potential, but the urgency of war created conditions where ethical reflection was often overshadowed by the perceived necessity to end global conflict. The deployment of atomic bombs on Hiroshima and Nagasaki in 1945 showcased the terrifying capability of nuclear weapons to annihilate entire cities almost instantly. While the war ended shortly thereafter, the ethical, social, and environmental consequences reverberated across generations. The dangers of atomic power extend beyond warfare. The development of nuclear energy for civilian purposes, such as electricity generation, introduced additional risks that humans were initially ill-prepared to manage. Nuclear power plants rely on complex systems that must function flawlessly to prevent catastrophic accidents. Failures in design, maintenance, or oversight have already led to disasters like Chernobyl in 1986 and Fukushima in 2011, demonstrating that even sophisticated technologies remain vulnerable to human error, natural events, or unforeseen interactions. Humanity's confidence in controlling atomic energy mirrors a broader pattern of overestimating our capacity to manage extremely powerful technologies. Unlike conventional energy sources, nuclear reactions involve forces and consequences far beyond ordinary human experience. A single miscalculation can release radiation with long-lasting environmental and health impacts. This introduces moral and practical challenges that extend across generations, demanding unprecedented foresight and responsibility. The Cold War intensified the danger. As nations raced to stockpile nuclear weapons, human error, miscommunication, and misjudgment became existential threats. Incidents such as the Cuban Missile Crisis of 1962 and various false alarms in later decades highlight how close humanity has come to accidental nuclear war. The combination of complex technology, imperfect information, and political tension created a situation where a simple mistake or misinterpretation could trigger global annihilation. Moreover, the production and storage of nuclear materials pose ongoing hazards. Spent nuclear fuel, radioactive waste, and plutonium remain dangerous for thousands of years, requiring management strategies that exceed the lifespan of civilizations. The challenge is not merely technological, but also societal. How to ensure that future generations, decades or centuries from now, understand the risks and continue to handle these materials safely. This represents a profound ethical dilemma. The consequences of today's decisions extend far beyond our immediate lifetimes. The psychological dimension of nuclear weapons also exemplifies a dangerous human mistake: underestimating fear as a factor in decision-making. Nations often plan and strategize under the assumption of rational actors, but human behavior is rarely perfectly rational under extreme stress. Misperception, panic, or miscommunication can convert a calculated strategy into catastrophe. The sheer scale and speed of atomic destruction amplify the stakes, making even minor misjudgments potentially disastrous. Atomic power also intersects with another dangerous mistake: secrecy. The initial secrecy surrounding nuclear weapons development prevented broader societal debate and understanding, concentrating immense power in the hands of a few scientists and military officials. While secrecy may have been justified by wartime imperatives, it demonstrates the risk of concentrating knowledge and decision-making authority without sufficient checks, balances, or public awareness. Ultimately, humanity's engagement with atomic energy exemplifies both extraordinary ingenuity and terrifying hubris. The technology embodies the paradox of human progress. Our capacity for creation is matched by our potential for destruction. Unlike conventional mistakes, errors involving nuclear energy are not easily reversible. A misstep can have consequences that persist for centuries, affecting countless lives and the global environment. The lesson is clear: power without humility and oversight is dangerous, and the pursuit of knowledge must be paired with foresight, ethical reflection, and international cooperation. Humanity has learned the destructive potential of atomic energy, but the challenge is ongoing. Each generation inherits the responsibility to manage what previous generations created, demonstrating that the most dangerous mistakes are not merely technical, they are moral, ethical, and societal as well. Section 12. Climate Change. A slow-moving catastrophe of human making. Among the most dangerous mistakes humanity has ever made, the persistent alteration of Earth's climate stands out for its scope, subtlety, and inevitability if left unaddressed. Unlike sudden technological disasters, climate change is a slow-moving catastrophe, building over decades, yet with the potential to reshape civilizations, ecosystems, and life on a planetary scale. It represents a unique kind of human error, one rooted in short-term thinking, industrial ambition, and the underestimation of nature's interconnected systems. The Industrial Revolution, which began in the late 18th century, marked the beginning of a dramatic increase in greenhouse gas emissions. Coal, and later oil and natural gas, fueled industrial expansion, urbanization, and technological progress, transforming human societies. Yet, these advancements came with an unseen cost. Carbon dioxide, methane, and other greenhouse gases trapped heat in the atmosphere, gradually raising global temperatures. For decades, humans either failed to notice or chose to ignore the long-term consequences of burning fossil fuels, prioritizing immediate economic growth over environmental sustainability. By the 20th century, scientific research began revealing alarming trends: rising global temperatures, melting glaciers, increasing sea levels, and more frequent extreme weather events demonstrated that human activity was reshaping the planet's climate systems. Still, many governments, corporations, and individuals delayed meaningful action, illustrating a key component of this dangerous mistake: the human tendency to defer responsibility, particularly when consequences are diffuse, slow to manifest, or geographically distant. Climate change exemplifies the compounding effects of human error. Decisions made by industrial leaders, policymakers, and consumers collectively amplified a problem that individual actions alone could not have caused. Unlike localized disasters, climate change is cumulative. Centuries of emissions, deforestation, and environmental neglect interact with complex feedback loops. Melting polar ice reduces reflective surfaces, amplifying warming. Thawing permafrost releases methane, accelerating greenhouse gas accumulation. Rising temperatures disrupt ocean currents, creating unpredictable weather patterns. Each feedback loop is a reminder that human mistakes in one area can cascade into far-reaching, often unpredictable consequences. The impact of climate change is not evenly distributed. Vulnerable populations, those in low-lying coastal regions, arid landscapes, or politically unstable nations, bear the brunt of rising seas, desertification, and extreme weather. Paradoxically, those most responsible for greenhouse gas emissions often experience fewer immediate consequences, highlighting a moral dimension. The failure to equitably share responsibility exacerbates suffering and threatens global stability. Wars over water and food resources, mass migrations, and economic collapses could all become more likely as climate systems continue to destabilize. Humanity's cognitive biases have worsened this mistake. Immediate threats trigger action, while long-term abstract dangers are often underestimated. Climate change, with its slow, global progression, is difficult to perceive directly, making it easier to dismiss, downplay, or deny. Political polarization, economic lobbying, and misinformation have compounded the problem, delaying decisive action and increasing the eventual costs of mitigation and adaptation. This illustrates a critical point. The most dangerous mistakes are often those that unfold invisibly, quietly embedding themselves into systems until a tipping point is reached. Efforts to mitigate climate change illustrate the challenges of correcting such a vast error. Renewable energy technologies, reforestation programs, and international agreements like the Paris Accord represent collective attempts to reverse or slow human-induced warming. Yet the scale of the problem is immense. Infrastructure, social systems, and economies were built under assumptions of stable climate, making transformation both costly and politically complex. Even with decisive action today, some impacts are irreversible, demonstrating that dangerous human mistakes often require multi-generational responses. Climate change also underscores the role of technological hubris. Humanity assumed it could manipulate the environment without consequences, extracting resources, altering landscapes, and industrializing at a planetary scale. Unlike localized errors, the effects of climate change interact with the global biosphere, oceans, and atmosphere, creating systemic risks that surpass the control of any single individual, organization, or nation. It is a profound lesson in humility. The Earth's systems are interconnected, resilient in some ways, but fragile in others, and human intervention carries unforeseen repercussions. Ultimately, climate change is both a technical and ethical mistake. It is technical because it stems from material choices, fossil fuel combustion, deforestation, and industrial practices. It is ethical because it involves the decisions to prioritize short-term gain over long-term survival, and to neglect the welfare of future generations. The danger is not just environmental. It is societal, moral, and political. How humanity responds now will determine the legacy of this error and whether it can be contained before its consequences become catastrophic. The slow unfolding of this mistake makes it particularly insidious. Unlike sudden disasters, climate change allows complacency, denial, and delay, encouraging humans to underestimate the urgency of action. Yet, the science is clear. Temperature rise, sea level increases, and extreme weather events are accelerating. Humanity faces the ultimate test of foresight, cooperation, and resilience. The failure to act decisively would cement this as one of the most consequential mistakes in human history, a cautionary tale of what happens when ambition and short-term thinking overshadow humility, responsibility, and respect for the natural world. Section 13. Lessons from humanity's most dangerous mistakes and the road ahead. Reflecting on humanity's most dangerous mistakes reveals a common pattern, a combination of ambition, short-sightedness, and underestimation of consequences. From technological blunders and military miscalculations to environmental mismanagement, these errors share one defining feature. They stem from the human tendency to act without fully understanding or respecting the systems in which we operate. The path forward requires acknowledging these mistakes, understanding their root causes, and fostering a culture of foresight, humility, and ethical responsibility. History teaches us that mistakes often result from overconfidence. The creators of nuclear weapons, the engineers behind flawed infrastructure, or the decision makers who ignored early warnings about pandemics, all acted under the assumption that their control was absolute and their knowledge sufficient. Yet, the consequences of these actions reveal a fundamental truth. No individual or society can fully predict the cascading effects of complex systems. Recognizing this uncertainty is the first step toward avoiding catastrophic errors in the future. Another recurring lesson is the cost of neglecting ethical considerations. Many of the most dangerous mistakes occurred not solely because of technical errors, but because human welfare, morality, or long-term consequences were subordinated to short-term goals, personal ambition, or national interests. The environmental degradation caused by industrialization, for instance, was not just a scientific oversight. It was a failure to consider intergenerational justice and global equity. Similarly, military blunders often reflect a moral failure to weigh the human cost of action. By integrating ethics into decision-making, humanity can temper ambition with responsibility. Learning from past errors also highlights the importance of humility. Complex systems, whether ecological, technological, or social, often defy simple understanding. Attempts to control or manipulate them without full comprehension can produce unintended consequences. For instance, early industrial chemicals promised immediate economic benefits, but created long-term health and environmental crises. The lesson is clear. Progress must be balanced with caution, and expertise must be coupled with respect for uncertainty. Education and transparency emerge as crucial tools in preventing dangerous mistakes. Societies that value critical thinking, open debate, and access to accurate information are better equipped to anticipate risks and question flawed assumptions. The suppression or distortion of knowledge, whether through secrecy, censorship, or misinformation, amplifies human error by limiting the collective ability to foresee consequences. A culture that encourages curiosity, scrutiny, and debate creates a safeguard against repeating past errors. Collective action is another essential factor. Many historical mistakes were magnified by fragmented decision-making, lack of cooperation, or unequal distribution of knowledge and resources. Whether addressing climate change, global pandemics, or technological risks, No single individual or nation can act in isolation. Coordinated, cooperative approaches that consider global consequences can mitigate risks and distribute responsibility more equitably. The failures of the past remind us that collaboration is not optional. It is a necessity for survival in an interconnected world. Preparedness and adaptability also stand out as key lessons. While some mistakes were sudden, others, like environmental degradation or pandemics, unfolded gradually, offering opportunities for intervention. Societies that invest in monitoring, contingency planning, and adaptive strategies are better equipped to respond to emerging threats. The lesson here is that vigilance and flexibility are critical to minimizing the impact of human error. Waiting for catastrophe to strike before responding is both dangerous and avoidable. Human imagination and creativity, often sources of progress, can also be harnessed to prevent mistakes. Scenario planning, simulations, and foresight exercises allow societies to anticipate potential outcomes and weigh risks before committing to action. By envisioning worst-case scenarios and preparing accordingly, humans can avoid repeating errors that arise from overconfidence or narrow thinking. The capacity to imagine, coupled with the discipline to act prudently, becomes a powerful defense against catastrophic mistakes. Finally, humility before nature and systems is essential. Many of humanity's most dangerous mistakes, from ecological disasters to technological failures, stem from underestimating the power and complexity of natural and systemic forces. A respectful, informed approach that treats the world not as a resource to exploit, but as a network of interconnected systems to navigate is crucial. The failure to do so has repeatedly led to suffering, loss, and irreversible consequences. Learning from history is not just an academic exercise. It is a moral imperative to safeguard future generations. The story of human error is also a story of resilience and learning. Even in the aftermath of monumental mistakes, societies have often demonstrated the capacity to rebuild, reform, and adapt. The invention of safer technologies, the establishment of environmental protections, and the development of international treaties all reflect humanity's ability to learn from past errors. While mistakes are inevitable, their recurrence is not. By studying past failures, embracing humility, and fostering ethical responsibility, humans can reduce the likelihood of repeating history's most dangerous errors. In conclusion, the most dangerous mistakes humans have ever made, from accidental technological catastrophes to global environmental mismanagement, highlight the delicate balance between ambition and prudence, knowledge and humility, action and foresight. These lessons are timeless. Act with awareness, consider long-term consequences, integrate ethics into decision-making, and collaborate across boundaries. The capacity to learn from past mistakes is humanity's greatest defense against repeating them, offering hope that even in the face of past errors, the future can be guided by wisdom, foresight, and responsibility.